Good morning everybody. In the previous lecture we have seen section formula, in which we have proved two theorems, section formula for internal division and section formula for external division. Also we have seen centroid formula for triangle as well as centroid formula for tetrahedron. Now today we are going to see the examples on the basis of these formulae. Now let's see the first question from exercise 5.2. So question first. Find the vector of point R. Find the vector of point R which divides the line joining the points P and Q, whose position vectors are 2i cap minus j cap plus 3k cap and minus 5i cap plus 2j cap minus 5k cap respectively. In the ratio 3:2 internally. Second sub question, externally. Means here we have to find out the position vector of the point R which divides the segment PQ internally in the ratio 3:2 as well as externally in the ratio 3:2. Okay, let's see. Let P bar, Q bar and small r bar be the position vectors of points P, Q, R respectively. So therefore small p bar is equal to 2i cap minus j cap plus 3k cap and q bar is equal to minus 5i cap plus 2j cap minus 5k cap. Now firstly suppose the point capital R with position vector r bar divides segment PQ internally in the ratio 3:2. So now here we have to use section formula for internal division. So therefore by section formula R bar is equal to 3 into Q bar minus 2 into P bar divided 3 plus 2 into 3Q bar plus 2 into P bar divided by 3 plus 2. See, this is section formula for internal division, so it is plus here. Okay, R bar is equal to 3 into Q bar plus 2 into P bar divided by 3 plus 2. Again, R bar is equal to 3 into Q bar. Now Q bar is here. What is Q bar? Minus 5i cap plus 2j cap minus 5 k cap plus 2 into p bar. What is p bar? 2 I cap minus j cap plus 3 k cap divided by 3 plus 2, and you know that 3 plus 2 is 5. Again it is equal to, multiply to this first bracket by 3, so we get minus 15 into I cap plus 6 j cap minus 15 k cap plus 2 into 2 4 I cap minus 2 j cap plus 2 into 3 6 k cap divided by 5. Again it is equal to. Now on the numerator, take the addition of I cap with I cap, j cap with j cap, and k cap with k cap. So minus 15 I cap plus 4 I cap. Minus 15 plus 4 become minus 11 I cap. 6 j cap minus 2 j cap, that is plus 4 j cap. Minus 15 k cap plus 6 k cap minus 15 plus 6, that is minus 9 k cap divided by 5. So again it is equal to, divide to each term at the numerator by 5, so we get minus 11 divided by 5 into I cap plus 4 divided by 5 into j cap minus 9 divided by 5 into k cap, or this can be written as minus 11 by 5 into I cap plus 4 by 5 into j cap plus minus 9 by 5 into k cap, and now this is R bar. So this is the position vector of the point R which divides the segment PQ internally in the ratio 3:2. Also here we have to find out the position vector of the point R if point R divides segment PQ externally in the ratio 3:2. So we see second sub question. So suppose the point R which R bar divides segment PQ externally in the ratio 3:2. So therefore by section formula, here we have to use section formula for external division, and it is R bar is equal to 3 into Q bar minus 2 into P bar divided by 3 minus 2. So again R bar is equal to, see here, 3 into Q bar minus 2 into P bar divided by 3 minus 2, and 3 minus 2 become 1. Again it is equal to, see, multiply to the first bracket by 3, so we get minus 15 into I cap plus 6 into j cap. 3 into minus 5 become minus 15 k cap, minus 2 into plus 2 minus 4 I cap, minus minus become plus 2 into j cap, and minus 6 into k cap. Now denominator is 1, so there is no need to write it. Again it is equal to minus 15 I cap minus 4 I cap become minus 19 I cap. 6 j cap plus 2 j cap plus 8 j cap, and minus 15 k cap minus 6 k cap minus 21 k cap. So this is your R bar. So therefore R bar is equal to minus 19 I cap plus 8 j cap minus 21 k cap. And now this is the position vector of the point R if the point R divides the segment PQ externally in the ratio 3:2. Now this is the complete solution for the question number 1. Now let's see question 2. Question 2. Find the position vector Find the position vector of midpoint of joining the points L, capital L, having coordinates 7, -6, 12, comma N, capital N, 5, comma 4, comma -2. Okay. So see here, M is the midpoint of the line joining these 2 points L and N. And we have to find out the position vector of the point capital M. Let small L bar, small m bar and small n bar be the position vectors of points capital L, capital M and capital N respectively. Now point L and N are given here, so we can write small L bar and small n bar. So therefore small L bar is equal to 7I cap minus 16 J cap plus 12 K cap, and n bar, because point n is given here, so small n bar is equal to 5I cap plus 4J cap minus 2K cap, and small m bar that we have to find out here. The point capital M with small m bar is the midpoint of segment LN. Small m, capital M is the midpoint of the segment LN. So by midpoint formula, so what is midpoint formula? R bar is equal to A bar plus B bar divided by 2 if the capital R divides segment AB in the ratio 1:1. So by midpoint formula, small m bar is equal to L bar plus n bar divided by 2. L bar plus n bar divided by 2. So again it is equal to, what is L bar here? 7I cap minus 16J cap plus 12K cap. This is your L bar plus n bar. What is n bar here? 5I cap plus 4J cap minus 2K cap divided by 2. Now take the addition of two vectors on numerator. See, m bar is equal to, small m bar is equal to 7I cap plus 5I cap. 7I cap plus 5I cap, 12I cap. Minus 16J cap plus 4J cap. Minus 16 plus 4 become minus 16 plus minus 16J cap and plus 4J cap. Minus 16 plus 4 become minus 12J cap. 12K cap minus 2K cap. 12K cap minus 2K cap, that is plus 10K cap divided by 2. Again it is equal to. Divide to each term at numerator by 12. So it is 12 upon 2 I cap minus 12 upon 2 J cap plus 10 upon 2 K cap. It is equal to 6 I cap minus 6j cap plus 5k cap. So this is m bar. So therefore m bar is equal to 6 into I cap minus 6 into j cap plus 5 into k cap. So this is the midpoint, or means the position vector of the midpoint M. We see next question number 3. Question 3. If the points A 30P, point B -1Q3 and point C -330 are collinear, then find the ratio, there are two sub questions in this question. Then find, first one, the ratio in which point C divides segment AB, and his second sub question, that is B here, the values of P, Q. In this question there are two sub questions. In first we have to find out the ratio in which the point C divides the segment AB, and in the second sub question we have to find out the values of P and Q if ABC are collinear. So let's see. Let capital A 30P, point B -1Q3 and point C -330 are collinear. They are collinear. Let small a bar, b bar, c bar are position vectors of capital A, B, C respectively. Now the 3 points are given, their coordinates are given, so we can write small a bar, b bar, c bar. Small a bar 3I cap plus 0j cap plus P into k cap. Small b bar is equal to -1 into I cap plus qj cap plus 3k cap, and c bar is equal to 3 that is -3I cap plus 3j cap plus 0 into k cap. So here we have written a bar, b bar, c bar. Now we have to find out the ratio in which point C divides segment AB. Now in the remark of the first theorem we have seen, whenever it is asked in the example that find out the ratio, at that time it is convenient to take the ratio as k as to 1. If k is positive, then that point divides the segment internally, or if k is negative, then that point divides the segment externally. Let the point C divides segment AB in the ratio lambda as to 1. Here we have taken the ratio as lambda as to 1 because in A bar, B bar, C bar there is k, and if we take k as to 1, so there may be some confusion with k and k cap. So that's why here we have taken lambda as to 1. So by section formula, small c bar is equal to lambda into b bar plus 1 into a bar divided by lambda plus 1. Divided by lambda plus 1. This is bisection formula. Now here we are interested to get the value of lambda. Now c bar is there, minus 3 I cap plus 3 j cap plus 0 into k cap. That is c bar is equal to lambda into b bar. What is b bar? Minus I cap plus q into j cap plus 3k cap plus 1 into b bar, that 1 into a bar, that is a bar, and a bar is there 3 I cap plus 0 j cap plus p into k cap divided by lambda plus 1. Now shift this lambda plus 1 to left hand side, so it is lambda plus 1 into minus 3 I cap plus 3 j cap plus 0 k cap is equal to. Now multiply to this bracket by lambda here first, minus lambda into I cap plus lambda q into j cap plus 3 lambda into k cap plus 3 I cap plus 0 j cap plus p k cap. Now here it is 1, denominator is 1, so no need to write. Multiply to this bracket by lambda plus 1, so it is minus 3 into lambda plus 1 into I cap plus 3 into lambda plus 1 into j cap plus 0 into lambda plus 1 again 0 k cap is equal to, see, minus lambda into I cap and here plus 3 into I cap. So if we take I cap common, we have the remaining term, that is 3 minus lambda into I cap. Similarly lambda q into j cap plus 0 into j cap, so that is plus lambda q into j cap plus 3 lambda into k cap and plus p into k cap. K cap and k cap take common, so the remaining terms are 3 lambda plus p. Now on the both sides there are vectors. Here it is one vector in the form of ijk. On right hand side there is a vector in the form of ijk, and these two vectors are equal, so their corresponding components means coefficients of I cap, j cap and k cap are equal. So by equality of vectors, see here, the coefficient of I cap is minus 3 into lambda plus 1 is equal to, here the coefficient of I cap is 3 minus lambda. Give this equation number 1. Now equate coefficient of j cap, that is 3 into lambda plus 1 is equal to lambda into q. Give this equation number 2. Now equate coefficients of k cap, here the coefficient of k cap is 0 is equal to, and on right hand side the coefficient of k cap is 3 lambda plus p. Give this equation number 3. Now from equation 1, so minus 3 lambda minus 3 is equal to 3 minus lambda. So shift this lambda to left hand side, so it becomes lambda minus 3 lambda is equal to, shift this minus 3 to right hand side, so it becomes 3 plus 3. So lambda minus 3 lambda minus 2 lambda is equal to 6, so lambda is equal to minus 3. Here we get the value of lambda is minus 3. Put this value of lambda in equation 2. Put lambda is equal to minus 3 into in equation 2. So here 3 into lambda, that is minus 3 plus 1, is equal to minus 3 into q, because lambda is minus 3. 1 minus 3 minus 2, and minus 2 into 3 minus 6 is equal to minus 3q. So minus 6 divided by minus 3 is equal to q. So 3 minus minus become plus, and 3 2s are 6, so q is equal to 2. This is the value of q. Similarly, put the value of lambda in equation 3. Put lambda is equal to minus 3 in 3. So 0 is equal to 3 into minus 3 plus p. That is 0 is equal to minus 9 plus p. So therefore p is equal to 9. So in this way we have q is 2, p is 9, and lambda is minus 3. Now as the lambda is minus 3, so here the point C divides the segment AB externally in the ratio 3:1. So we have to write one sentence at the last. That is, here the negative value of lambda suggests that the point C divides segment AB externally in the ratio 3:1. So in this way, this is the complete solution for question number 3. And today we stop it here. In the next lecture, we will see the remaining examples. Okay, thank you.